Good morning everyone. I welcome you all in another session of Project Management for Managers course. The topic which we have been studying is risk analysis for standalone project, and we have seen several methods like sensitivity analysis, scenario analysis, break-even point. Let us look at one more analysis. It is called simulation analysis. So, as I said in my earlier lecture that sensitivity analysis will give you how output will change by change in one variable, but it does not give you the probability of that change, and the managers and decision makers are interested in knowing what would be the probability of that change, and that can be calculated using simulation analysis. Right. So, this information means the information about likelihood of happening a particular change can be generated by simulation analysis, which may be used for developing probability profile of a criterion of merit by randomly combining values of variables that have bearing on chosen criterion. Right. So, let us not discuss this analysis in detail, but we will move on to Hillier model of risk calculation. And before I go for Hillier's model, let me remind you that what is risk? Risk is the probability of happening an event and its consequences, right. So, that is risk. So, if you look at probability distributions, then basically there are two types of probability distribution. So, you should know what is probability distribution first of all, right. I will give you an example. Let us say if I contest an election, then I will get 50 votes. Let us say total electorates are 100, right. I will get vote of 50 people, its probability is 0.6, right. I will get vote of 70% or 70 people, its probability is 0.4, right. So, I can draw a probability distribution like this, right. So, 50 and 70, so this, and let us say this is 0.6 and this is 0.4, right. So, this is nothing but a kind of, this is nothing but probability distribution. So, you can have different probabilities over here, but the sum of the probabilities should be 1, right. So, this is probability distribution. So, you can have two types of probability distributions. You can have discrete probability distribution and continuous probability distribution, and there are several discrete probability distributions. For example, let us say binomial distribution is basically a discrete probability distribution. You have got Poisson distribution, and if you talk about continuous distribution, then normal distribution is a continuous distribution. So, let us look at an example of risk with discontinuous probability or discrete probabilities. When there are three outcomes with some expected probabilities in each event as given in next slide, right. So, we have to calculate total profit or expected profit, right. So, here again three scenarios have been taken. So, when situation is favorable, profit from a project is 40 lakh rupees, right, and its probability is 20%. Average situation profit would be less than 40 lakh, and in this case it is 20 lakh, right, and unfavorable situation profit is, in fact there is no profit, it is a loss of 10 lakh rupees, right, and probability is 30%, right. So, expected profit would be very simple, right, you just multiply these three values. So 0.2 into 40, 8 lakh, 0.5 into 20 is 10 lakh. So 8 plus 10, 18 minus 3, right. So expected profit would be 15 lakh, right. So this is a kind of discrete probability distribution, right. So this is your expected profit, right. Now let us take an example of risk with continuous probability, and a continuous probability distribution like normal distribution. Generally we represent normal distribution through mean and standard deviation. So this is mean and standard deviation, right. This is how we represent our normal distribution. So mean is this, right. This is your mean, and you will have different limits here. Let us say this is 1 sigma limit, right. So plus 1 sigma, plus 2 sigma, and plus 3 sigma, right. So this minus 1 sigma, minus 2 sigma, and minus 3 sigma, right. So area under this normal curve is unity, that is 1, right. In other words, we can say that this area is 50% and this area is 50%, right. So just keep in mind this point and then we will solve our question, right. So an example of risk with continuous probability is normally distributed, where average profit is 15 lakh with standard deviation of 6 lakh, right. So mean is 15, right, in this case 15 lakh and standard deviation is 6 lakh, right. What is the probability of earning at least 10 lakh can be calculated, or you have to calculate what would be the probability of earning at least 10 lakh rupees profit from this particular project, right. So how to solve this question? So this is mean 15 lakh and standard deviation is 6 lakh, right. What we have to calculate, what is the probability there? Probability of earning at least 10 lakh rupees. So 10 lakh would be somewhere here, right. This 10 lakh, right. So we want to calculate area under this shaded portion, right. And we also know that this particular area is 0.5, right, and this is 0.5. So how to find out this particular area? This one. For this you need to use Z table, right, and this is Z table, right. Now if you look at this particular table, this point is mean, right, and this point is 2.24. So Z value is 2.24 and area from mean to Z equal to 2.24 is 0.4875, right. Is this point clear? Let me repeat. This is your mean value and let us say Z value is 2.24. So area under curve would be 0.4875. How did you get this 0.4875? 2.24. So look at Z value of 2 first. This is 2, right. then 2.24, right, this is 2.2, which is 0.4783. The next one is 2.3, 2.3 is this, 2.3 is 0.4871, right, and 2.24 is this one, 2.24, this one, right. So 0.4875 is written here in this table, right. You need to look at this value very carefully, right. So if I ask you what is this area, the remaining one, you just subtract this area from 0.5, right. So let us calculate Z value first. Z is nothing but standardized normal distribution, right. So how to calculate Z for this question? Z is equal to x minus mu divided by standard deviation, right. So here x is nothing but this 10 lakh value, right, mu is 15, right, sigma is 6, right. So this is 10 minus 15 divided by 6, so this minus 5 by 6, right. So minus 5 by 6 is what? Minus 5 by 6, you just calculate. So this is, let us say, 0.8 minus 0.83, isn't it? So minus 0.833. Now let us look at what is the area under curve when Z is minus 0.833, right. So this, in other words, this is your Z value, right, it is minus 0.833, right, isn't it? So we have converted this value into Z value, right. Let us look at what is Z value. So when Z is 0.83, right, so 0.8, right, is this, and 0.81, 0.82, 0.82, 0.83. So this is 0.2976. So this is 0.5, this side of the curve is 0.5, this side of the curve is 0.5. We want to know what is the area from here to here, right, and this area is what we have calculated from table, what we have said is 0.83, right, it is 0.2967. So this area is 0.2967, right. Let me put it like this. So this area is 0.2967. What we want to calculate? We want to know what is this area, right, this area. So how to do that? It is very simple, right. We know this, we know that the area under curve is 1, right, minus 0.5 0.5 plus 0.29. So this becomes 0.7967, right. So this area is 0.7967. So the probability that the project will earn less than 10 lakh rupees is this, no, it's 1 minus this, and probability that it will make more than 10 lakh rupees is 0.7967, right. So this is how you can solve this question, right. So this 0.7967 is the answer, right. So at least, so less than 10 lakh rupees, its probability is this one, and more than that is 0.7967, right. So this is how you can solve a question very easily, right. Now let us look at Hilliard's model of risk calculation. Now this is a very simple model. First of all, the plus point of this model is it can be used for both continuous distribution as well as for discrete distribution. We need to convert first of all the given values and probabilities, we will find NPVs and then standardized NPV, right. So let us look at this question, very important question. A project with initial investment of 100 lakh with a lifespan of 4 years has the following probabilistic outcomes in different years, right. So this is our question. What we have to find out? Determine the expected net present value of the project and its standard deviation. Two things we need to calculate first. Then in second part of the question, determine the probability of positive NPV of 30 lakh and what is the probability of project going in loss, right. Assume 10% as discounting factor, right. So this is the question which we will be solving, right. So let us look at first year, year 1. Net cash flow is given, NCF net cash flow 50 lakh, 30 lakh and 10 lakh. Probability of achieving this much cash flow is 0.2 or 20%, 50% and 30%. Just keep in mind that this total is 100%, right. This for first year, right. For second year you have got net cash flow as 60, 40 and 10, 60, 40 and 10 and probabilities are 25, 50 and again 25, right. So this is in terms of percentage, right. So probability in terms of percentage, right. Third year net cash flow probability in terms of percentage, it's 70, 40 and minus 10, 70, 40 and minus 10 and probabilities are 40, 50 and 10, 40, 50 and 10, right. And for fourth year this is 60, 40 and 20 and probabilities are again in terms of percentage you have got 30, 55 and 15, 30, 55 and 15, right. So this total is again 100, right. So what's the question? Determine the expected net present value of the project and its standard deviation, right. So how to determine expected net present value of the project in first year? What you should do? 50 into 0.20 plus 30 into 0.5 then 10 into 0.3, right. So this is how you can calculate NPV, okay. So let's do it. So in first year in first year is 50 into 0.2 plus 30 into 0.5 plus 10 into 0.3. This is equal to what? This is 10 lakh, 15 lakh, 25 lakh plus 3, 28 lakh, right. Similarly, second year 60 into 0.25 plus 40 into 0.5 plus 10 into 0.25. What this value would be? So this is 15 lakh, this is 20 lakh, 35, and this is 2.5, 32.5 lakh, right. It's not 32.5, just check this. This is 15, this is 20, 35 plus 2.5 is 37.5, right. For third one, it's 70 into 0.4 plus 40 into 0.5 plus minus 10 into 0.10, right. So this is 28 lakh plus 20, 48 minus 1 is 47. Yeah. So for third year it is 47 lakh, right. For fourth year, what this would be? It's 60 into 0.3 plus 40 into 0.55 plus 20 into 0.15. So this is 18 lakh, and this you need to calculate, and this is 3 lakh, right. So this total would be, I will give you answer, this 43 lakh, right. So this how you can calculate NPV of each of those 4 years, right. Now we need to calculate NPV because we have been given discounting factor of 10%, right. So what you should do, it is 28, you need to discount this value, right, and discounting factor is 10%, right. So 1.10, 28 divided by 1.10 plus 37.5 divided by 1.10 and square of this, right. This is what we have seen when we calculated discounted payback period method, right. The next one would be 47 divided by 1.10 cube, then you got 43 divided by 1.10 to the power 4, right. So this is your NPV, and of course since your initial investment is 100 lakh, right, so minus 100 you will get NPV, and this value you can calculate. Let me give this value is 21.13, right. So now let us calculate standard deviation of each of those 4 years. Before calculating standard deviation, let me summarize what we did in this session. We have seen how to find out, first of all we have seen simulation analysis. We use simulation analysis in highly uncertain situation, and it gives us probability values of occurrence of an event, right. Then we have seen Hilliard's models, and we have also seen how to calculate probability at a particular we have also seen what is the area under curve at a given z value, and in normal distribution the center point is mean, and its distribution we represented it by standard deviation. And keep in mind that the each side, because it's a symmetric curve, right. So and the area under curve is 1. So area under one half is 50% and in other half it is 50%. So we have seen how to calculate probability when z value is given, and what is z? Z is standardized normal distribution, and how to calculate z value? It is x minus mu divided by standard deviation. So let us, I do not think we have sufficient time to calculate variance for all the projects. Anyway, let us try to understand what is the variance for first year. So this is probability 0.2 multiplied by 50 into NPV of first year, right. Then probability 0.5, this one multiplied by what? It is multiplied by 30, right, minus projected cash flow of second year, right. Similarly, for first year and third value it is 0.3 into net cash flow minus projected cash flow, right, 28 whole square. So you will get 196. In similar way you can calculate sigma 2 square, sigma 3 square, sigma 4 square, right. And after calculating all those variances, these are nothing but variances, right. We should calculate the z value, because we want to know what would be the NPV, what is positive NPV of 30 lakh, right. So we need to calculate that probability. So you need to calculate z value for this, and one more time you will have to calculate z value for this one, right. Once z values are obtained, look at area under the curve and find out what is exact probability. So we will do that thing in next session. Thank you very much for watching this particular lecture. Thank you.